on Tuesday, I have give you a little bit of nightmare. So now I will continue to give you another torture. And it is now about the momentum. Okay, you know momentum? Yeah, you know the momentum. Okay, and sorry to destroy your nice dream about F is equal to MA. It's no more like that. Right? It is dmp over dt equal to the summation of F. Right? So now you know that this is the true story about it. Or rather than fx, I will just put F. Before you get too worried about it, I will not ask you to derive it. So don't worry about it. Okay? Even my lovely assistant said that during her time, it is not explained. But I think I have to explain to you so you know where it comes from. I can just show you, okay, Navier Stokes is this. But maybe one of you or some of you ask me how you get that. Okay, so I will just show you how to get it. It comes from here, right? And this one is the change of momentum in the system, and this one is the summation of the force working on that. Now from this one, you can convert it because you know we are taking a very small volume. When you have a very small volume, you have a very small mass. When you have a very small mass, it becomes this dm, right? And this dv dt is nothing but your acceleration term. But your acceleration term is not as simple as what you thought before. Now you have all those things. Okay? So you have this. Right? So this one settle. This one settle. There. Okay? I think you don't want me to explain one by one with that, right? I just want to see that's it. If you trust me, that's the result. If you don't trust me, derive on your own. Okay? Hopefully you don't trust me then. You derive on your own. Okay, now the problem now is with this one, the F. For a fluid, maybe you have heard about it in the fluid mechanics 1. There is two kind of force working on the fluid volume. One is body force, the other one is surface force. For the body force, usually the only force is good. So we can skip that one. Huh? Don't worry, later on I will show you the equation. And the other one is the surface force. The surface force is the one that I told you before. It can be a pressure force, it can be a shear force. Okay, the pressure force is only working on this direction. Okay, you have one, no problem at all. But the shear force can be working to that direction, that direction, this direction, that direction. And you have this plate, this plate, that plate, that plate, that plate. Okay, in total, what will you have? Huh? Pain and nightmare. Okay, so just to differentiate, usually normal stress is given by this sigma. We call it sigma. Up to you if you want to call it something else, just name. Okay? Even if you name rose as something else, it's still rose. Right? This one, top. Okay? Shear stress is top. Okay, so yes, this is what you will have. Taylor series is there again. Okay, so you have left, right, front, rear, top, bottom. In total, you have 1, 2, 3, 4, 5, 6. 6 face, right? For a cube. Okay? Now if you sum all of those, you take s, y, s, x. This is xx. This, so right face minus left face, top minus this minus that. Okay? And remember, this one is only in x direction. This one is only in the x direction. So you need to do the same for the y and z direction. Homework. If you want to do. If you don't want to do, just believe this one. Okay, so you have a component of x, y, z. That one is not for the total direction, it's only for the x. If you do the same for the y, you will get this. Okay, you repeat again for the z, you will have this one. Okay, if you want, we can do the derivation during the tutorial, if you want. If you feel like, oh, I want to take this challenge to do the derivation, just tell me, then we can do it during the tutorial, not during the class. See, even your friends say, no. But it's very lovely here. Do derivation is really nice thing to do. Okay, that one is the surface force. Now we are talking about the body force. The body force is nothing but the gravity. And gravity is equal to m times g. Right? Because we are talking a very small volume, of course the mass is very small. Right? The mass is small, so you have dmg. Right? And dm is nothing but rho dv. You remember? When we are talking about conservation of mass, this thing is not s, small delta. It's very small, infinitesimal small. You need to take the component b in the x direction, body force in the y direction, and body force in the z direction. So you have rho dv is equal to rho dx dy dz, right? So you have rho dy dx, dx dy dz gx, rho dx dy dz gy, rho dx dy dz dz. Okay? Most of the time, I'm not talking about the general, but most cases you are dealing with gy only. Because in this earth, our gravity is working to that direction. But it depends on your Cartesian coordinate. What happens if you have an inclined angle like this? So now your g will have component in x and will have component in y direction. Right? Okay, now we have our dmv dt settled. We have Fa, which has a component in Fs and Fb. Okay, this one you have component in x, in y, in z. This Fs you have normal, and here all of them you have x, y, z, x, y, z. This one unfortunately you have okay, not enough. You have dmv dt, you remember? The m goes out, then you have dv dt is equal to a. You have ax, ay, ez. M itself is equal to, dm is equal to rho d x y z. Right, so you have that, and A you have AX, AY, AZ. Fs you have two, normal and shear. For normal you have X, Y, Z component for each For sure you have x, y, z component for each. FB, you have x, y, z component also. So you can count now. 1, 2, 3, 4, 5, 6, 7, 8. Okay? This is a summary of those derivations. Don't worry about the derivations. So we recall that you have dmv dt is equal to df, where df is equal to surface force plus body force. Okay. Surface and body force, right? So you have surface and body force. Okay. So that thing, dv dt is equal to A. Now we have to split it according to the component wise. So in the x direction, you have dmax plus dfsx plus dfbx. This one is the surface component, this one is the body force component. The surface component, you have this. Remember how you get this? Using the Taylor series. Okay, when you do Taylor series, you can hear Taylor Swift song. Maybe it help you, maybe it make it worse. So you have this. So okay, you know, this one, I really wish I can do that. You can. This one is that. Clear? This thing is that. dm. dx is ax. bx is that. Because dx is nothing but m times g, right? Clear? M times g. This one m times a. That's the only thing. Simple, don't worry. It's very simple. You can take a drink. See, I feel bad now. Okay, so rho x, rho ax, if you want to expand it, you know ax is equal to du dt, u du dx, v du dy, w du dz. And this one become this, and this one come to there. What is missing there? You can see. What is missing from here to there? From here to there? The from here to there was the thing that disappeared. Dx, dy, dz. What's that? Volume. Very good. I think I can teach you faster.